All right, guys, so this is the last video of Module 2A, which provides a review of short-term memory and working memory, which was discussed in Chapter 5 of your textbook. And for this particular video, I have a special guest with me. So this is Marley, and Marley says hi. It's raining really hard right now, so she has requested to be in my lap at this time. So there we go. Yeah. Okay, so in this particular video, Marley and I are going to tell you about the central executive feature of the Badley and Hitch working memory model. Okay, so here we go. Okay, so the central executive, you might remember from my previous videos, the central executive is essentially the traffic cop of the working memory model, the Badley and Hitch working and memory model. And it's where all the working of working memory is done. The working component of working memory is done. So another way of saying that is that the central executive is the control center of the working memory system. So unlike the phonological loop or the visual spatial sketchpad, the central executive does not actually store any information, but rather it coordinates how information is used and how information is attended to between the phonological loop and the visual spatial sketchpad. Okay, so it determines how attention is focused on a particular task. So it focuses your attention on particular features involved in a task. It also allows you to divide your attention between multiple tasks, and it allows you to switch your attention when you are engaging in multiple tasks, right? Because remember, the objective of the Badley and Hitch working memory model was to explain not only how we can hold and process information simultaneously, but also how we are able to carry out more than one task at once. So how are we able to read and hold numbers in mind? How are we able to teach and also hold a very needy, spoiled, small dog, etc.? Okay, so continuing here, I'm going to talk about different kinds of scientific evidence, again, that seems to support this particular theory, the Badley and Hitch theory, and their concept of the central executive. So one of the best ways to find evidence for various aspects of cognition, such as the working memory model, is to look at what functions are absent in individuals that have sustained damage to regions of the brain that are thought to be involved in such cognitions. So this is my first example, is where a lot of the central executive's functions are thought to be represented in the brain is the prefrontal cortex. So the prefrontal cortex is the particular region of the brain that is involved with planning, attention, impulse control, and a lot of the things that characterize that central executive process or are related to the idea of the central executive. So when we look at individuals who have sustained damage to the PFC or the prefrontal cortex, we notice that they respond kind of uniquely to tasks where they have to solve a problem according to a particular rule. So let's say I have a table full of objects, and I say that in order to solve this particular problem or arrive at the correct solution, you can only choose or you can only utilize red objects. Okay? At least initially, patients are going to do really, really well with this task up until the point where the rule changes. So if I were to mix things up and say, okay, now I want you to focus exclusively on the purple objects, okay? Individuals with damage to the PFC are going to continue to utilize the red objects, okay? So really we see a deficit here in one of the most important components of the central executive, which is the ability to switch one's attention between tasks or to now ignore one thing in favor of something else, right? So we say that whenever you are unable to switch your attention, or whenever you're unable to ignore something that is no longer relevant, that is reflective of something called perseveration, right? So whenever you can't ignore something or switch your attention, you're engaging in perseveration, okay? And this perseveration is again caused by a breakdown in the central executive's ability to control your attentional system and help you to switch between tasks or to ignore information that is no longer relevant. Okay? And we'll see as we go throughout the semester that the prefrontal cortex is going to be involved in a lot of really important aspects of complex cognition. And one of the hallmark features of a lot of different neuropsychological disorders that affect cognition is going to be damage to the prefrontal cortex. Okay, so this is another example of a particular task that is illustrative of your central executive. So some of you might be familiar with this and you might remember it from your book, but this is called the Stroop task. And so what your job is whenever you complete this particular task is your job is to tell me as quickly as possible the ink in which the word is printed. Okay? So to solve this particular task, your job is to tell me the color of the ink in which the word is printed. Okay? So go ahead and pause the video if you've never done this particular task before. Go ahead and pause the video, and I want you to set a timer on your cell phone and measure how long it takes you to complete this task. Okay? So go ahead and pause the video for just a moment. And again, tell me as quickly as you can the color in which each word is printed. Okay, so one thing that you probably noticed right away is that there's a particular aspect of this task that makes it very challenging, and that is that there is a conflict, right? So each of these words denotes a particular color. Okay, so these are all words denoting various colors, but all of the words are printed in a different color. Okay, so right away there is a conflict. And we all have a dominant response here, or something that we've been very, very well trained to do. And that is, we all have an overwhelming desire, right? Or an overwhelming urge to read the word, right? So most of you, when you were doing this task, you would start out by saying black and have to correct yourself and say no, red. And you might have gotten a few of them right. So you might have said red, yellow, black, blue, green, right? But chances are at least once or twice you would say the word in the word that's denoted, or the color that's denoted by the word, rather than the color of the ink, right? So essentially what's happening here is, again, we have to rely on our central executive, okay, to help us to ignore the color that's denoted by the word and instead focus on the color of the ink, right? So if I were to use Donder's measure of reaction time and compare how many seconds it takes you to get through this list when it's organized like this, okay, chances are it would take you longer to complete this task as it's currently. Okay, so do you guys have any guesses as far as who that population might be that I was talking about? Well, if not, I was talking about preschoolers, or individuals who have not yet learned to read, right? And if you think about it, that makes sense, right? So all of us, our dominant response is to read the word, because that's what we've been doing since we were in kindergarten, is whenever we see a word, we attempt to read it, right? But for individuals who have not yet gone to school or have not yet learned to read, that is not their dominant response. Their dominant response, though, having recently learned their colors, is going to be to focus on the color of the word, right? And therefore, they're not going to show a slower reaction time when the words denote different colors as compared to when they denote the same colors, because they're not able to read. Okay? So here's just a couple more examples of the Stroop task. So go ahead and pause it and go through each of these. And what I would like you to tell me is the position of the word that you see in each of the boxes. Okay, so is the word positioned up? Is it down? Is it left? Or is it right? Okay. So go ahead and answer that question for each of the boxes. Okay, so now I'd like you to do the same thing. Tell me the position of each of the words that are presented in the boxes. Okay, so what you probably noticed, I'm hoping, is that it was considerably harder to complete that task in the second case when the direction denoted by the word was different than the actual direction of the word, right? So it's yet another example where there's that conflict where our dominant response of reading the word is contradictory or different than the actual direction of the word, right? So whenever we have to switch our attention from our dominant response and instead focus on a different feature or a different aspect of the task is going to be slower and much more effortful, right? So both of these examples are illustrative of our central executive's ability to switch our attention and help us to ignore information that is no longer relevant to us. Okay? Um, so what I want to focus on in this slide is revisions that have been made to Badley's original three-component model. So we have seen that Badley's three-component model can explain results such as the phonological similarity effect, the word length effect, the articulatory suppression effect, mental rotation, and how interference or conflict can affect our central executive, and how also overloading our visual spatial sketchpad can make it harder to complete tasks that require us to process visual spatial information. However, research has shown that there are some things that the three-component model can't explain. So I'm going to go through some of those examples with you. So one of those things is that working memory can hold more information than would be expected based on just the phonological loop or the visual spatial sketchpad. So for example, people can remember really, really long, complex sentences that have as many as 15 to 20 words. Okay? So in the original model, we would expect that to completely overload the phonological loop. So remember, our phonological loop is a limited capacity system, okay? So we wouldn't expect that it would be able to hold that much information. Okay? So that's one of the problems, is that we're able to process more information than would be predicted by these three components alone. Okay? So another issue is that not only are we able to hold 15 to 20 words in our mind at a time when we're reading complex sentences, right? But we're also regularly able to, as we are reading a complex or lengthy sentence, to relate that sentence to content that's currently in our long-term memory, right? So if we are reading about birthday parties, right, while we are holding the words in our mind and putting them together, we're also able to think about our last birthday party, right, and think about that experience, maybe the kind of cake that we had, or the gifts that we received, or the guests that we had at our party, right? And we're also able to think about things like grammar and syntax and other sorts of arbitrary rules that have been stored in our memory as a result of our education, right? So the three-component model doesn't really allow for that. So the central executive does kind of interface a little bit with long-term memory, but not to the extent that we would predict in the three-component model. So in an effort to address some of these inconsistencies, in 2000, the year 2000, Alan Badley came out with a revised model which included two additions. One is something called the episodic buffer, and the last is just a space for long-term memory, right? Or mention of long-term memory. So a mechanism that allows for sort of the interchanging or interfacing between all four components of working memory and long-term memory. Okay, so the episodic buffer is a subsystem of working memory that handles the brief storage of episodic memories when the phonological loop or visual spatial sketchpad are otherwise engaged, or it handles that storage of information when the phonological loop and the visual spatial sketchpad are basically already overloaded with information, right? So that explains how we are able to retain long sentences, like 15 to 20 word sentences at a time. Okay, the episodic buffer is also responsible for integration. So it's going to allow us to combine phonological, visual, and spatial information together, okay, and create multifaceted or multidimensional representations in our long-term memory that include all of these components. Okay, and it's also going to serve as a link between working memory and long-term memory. Okay, so it's going to allow us to continually update our long-term memory with information currently residing in our working memory and vice versa, right? So it's going to allow for that constant interplay between working memory and long-term memory. Okay, all right, so this concludes my review of Badley and Hitch's working memory model and my review for all of Chapter 5. So thank you very much for watching, and Marley and I both appreciated your attendance today, and I will see you in my next video.